Alright, let's come back to the part that I have skipped just now, which is the IV characteristic graph. Okay, means that the graph is plotted of current against potential difference across these three things. One is the metal conductors, the second one is the filament lamp, and the third one is thermistor, which is semiconductor also. You can see that these three graphs they are very different from each other, and you actually need to know why are they different and how are they different from each other. Okay, we are going to look into the details of it. So first one, the metal or conductor basically is a straight line, as in it will obey the Ohm's law, but we have to make sure that the current is not too large, because the larger current will cause heating effect, and then afterwards it will affect the resistance of it. Okay, it will increase the temperature and therefore the resistance. So we are assuming that the current is not too large, and therefore it will be a straight line that obeys the Ohm's law. Okay, second one is the filament lamp. Filament lamp, we can see that it is not a straight line. Earlier part, yes, the starting part that you can see is yes, it's a straight line, but afterwards it shows that it started to curve, okay, as the voltage or current increase. Why is it so? Is because the temperature of the filament element inside there, as they glow when you increase the potential difference, means that there will be light and heat. So light and heat means it will cause the increase in the temperature of the filament, and therefore the atoms inside the filament, they will start to vibrate at a greater amplitude, and therefore that impede the motion of the free electrons. Remember earlier we said that resistance basically is the opposition to the movement of the flow of the free electrons. So if you have a greater vibration of the atoms, means that the free electrons will now find it harder to flow past, and therefore resistance is higher. Okay, so as the current increase, resistance will increase. Okay, and the graph will behave in such. Okay, resistance will increase. And next, if we look at the thermistor will curve up. Okay, filament lamp just now curved down, and thermistor will curve up. Why is that it behaves slightly differently? We can actually anticipate that how its resistance change, because earlier we know that when it curved down, resistance increase. So this one curve up means the other way lah, means that resistance actually decrease. Why is that a decrease for a semiconductor? So let's look at the explanation here. When temperature rise, it can cause an increase in the number of free electrons. Okay, semiconductor, the difference is that it doesn't have all the electron moving. It doesn't have all its electron moving freely compared to the conductor. Some of them are still tied to the nucleus, but as the temperature rise, this number they will have a great increment. Okay, suddenly it just become a lot of them, and therefore though the vibration of the atoms increases as the temperature rise, but they have now more electron to carry the charge or the energy. So they have now more electron as the current. Okay, so because of this, it outweighs or overweights the effect. Its influence is larger than the one caused by the vibration, and therefore the current increase, and therefore the resistance is reduced. Both happening, one is having greater influence to the overall happening or effect, so therefore the resistance reduced as opposed to the thing that happened to the conductor. Okay, so this explanation you need to be clear, yeah. And therefore as current increase, R decreases. So one more thing from the graph itself, how exactly that we can identify the resistance, whether it increase or decrease. Okay, you might be thinking that it is the because of the gradient, because it looks like when the gradient increases, the uh, the ratio of gradient increases, I over V increases, and therefore R is V over I decreases, right? But basically this is a wrong concept, because if you look at the definition, if you recall the definition of resistance again, it is the ratio of V to I. It's not the difference in V to the difference in I. Okay, in a way, mathematically, it's not the change in the Y divided by the change in the X. It's just a ratio of these two values only. And that itself is already the difference, yeah. So how do we actually identify from it if that's the case? So very simple. Every time you draw a line, starting from the zero to the point that you want to investigate its resistance. Okay, and another point, if you want to see how its resistance change, you just draw another straight line. So we compare the gradient of these two lines. We notice that the gradient of M2 is greater than gradient of M1. Therefore, the resistance of point 2 is less than resistance of point 1. Okay, it will work for every other situations. Okay, just draw a straight line from the 0 point to any point in the line, and then you trace the changes. So gradient increases as it move up here, move up the line. Therefore, the resistance decreases as it move up. Okay, you can try to do for the filament lamp just now, on how it curve and how its gradient changing as you draw these straight lines, and then you'll be able to figure out how its resistance change. Alright, so we'll stop here and see you in the next video.